All right, so today we're talking about negative exponents. We're going to add this to our foldable here at the end. So negative exponents, let's move on over here. So if we're talking about zero exponents and negative exponents, and then it tells us right here that any non-zero number to the zero power is 1. That sounds funny. So any base to the 0 power is 1. Anything to the negative power is the multiplicative inverse, meaning it's the fraction of it actually. So you can see some examples here, and we're going to go practice those on the bottom. So any number to the 0 power, always 1. So even if it's a really ugly thing, but it's all raised to the 0 power, it's just 1. Anytime you see a negative exponent, you can move it. If it's in the numerator, put it in the denominator. If it's in the denominator, move it to the numerator. Negative exponents don't want to be where they are. They're negative for that reason. So we move them to make them happy. So if they're in the numerator, we put them down in the denominator where they'll be happier because they'll be positive down there. If they're in the numerator or in the denominator, we put them in the numerator because they'll be happier there. So like this. Now you don't see a denominator and a numerator, but everything you can write it over 1. So now you see a numerator and a denominator. It's not happy in the numerator, so flip it. We just flip it. That's the multiplicative inverse. That's all we do, and we're done. We can write all of these over 1. They're all in the numerator, so they're all going to go to the denominator to be happy. Now they're not negative anymore. They're positive. And it says in the directions to use a positive exponent, so we can leave this as 1 over 7 squared and 6 cubed instead of the 1 over 49 and I think 216. So we're good there. Slide 4 says actually reverse what we were doing and write it with a negative exponent. I don't know why we would ever do that, but if we want this to be mad or negative or angry, to go from positive to negative, we would move it to the numerator since it started in the denominator. Here, this one's not an exponent, but what squared gives you 36? 6. So now it's positive. Make it negative and move it. We'll move it to the numerator. G, we would just move him to the top to make him negative. Okay, 27 isn't anything squared, but it is something cubed. It's actually 3 cubed. So to make that one negative, move it to the top. Moving on to slide 5, we can actually use our rules that we learned about bases with negative numbers. So the product of powers and the quotient of powers rule still can be used to multiply and divide. If we multiply same bases, we add the exponent. If you divide the same bases, we subtract the exponents. So those tricks are still going to help us right here. So 3 plus negative 5 is negative 2. So this will be 5 to the negative 2. We can rewrite that. It's a negative, so we'll put it in the denominator. There we have it. Number 7, we're going to subtract, because this is a division problem, negative 1 minus negative 4. This becomes a plus. Negative 1 plus 4 is 3. So we get w to the 3rd. Another way to think about this is these guys are both unhappy with where they are. So we would swap them both. And then 4 minus 1 is w to the 3rd. So 2 different ways of kind of thinking about the same problem. Moving over to slide 6, just adding negative 8 plus 2 equals 3 to the negative 6. That's not happy, it's negative, so we move it to make it happy and be positive in the denominator. 2 minus 4, since a division problem, is negative 2. So this would be 11 to the negative 2. It's negative, it's not happy, so flip it. 1 over 11 squared, or 11 over 121. Here we have some coefficients, so we still multiply those like normal. 3 times negative 5 is negative 15. 9 plus negative 4 equals negative 5. So this would be n to the negative 5. The n is not happy. The 15's content where it is. The 15 stays in the numerator, but the negative n moves to the denominator to become positive. This next one is a division problem. We still divide the numbers like normal, so 14 divided by 2 is 7. 3 minus 6 is negative 3. 7's happy, x is not. 7 stays, x to the third moves to where it can be positive. Okay, so then moving on to slide 7. Here we have some decimals. They want us to use the powers of 10. So it has a mass of, it's very, very light. Write the decimal to a power of 10 with a negative and a positive exponent. So this, I'm going to write it as a fraction, because this is a small number, 1 over, not tenth, hundredth, thousandth, 10,000. So 1 over 10,000, which that's 1 over 10 to the how many zeros? 1, 2, 3, 4. 10 to the fourth. There's our positive. To make them negative, we move them. There we have it. Now this next one is really, really tiny. So this is 1 over tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions. That tells me 10 billion has 9 zeros, so a total of 10 zeros. So that's 1 over 10 to the 10th, or 10 to the negative 10. Another kind of neat trick is that if you move your decimal, you would move it 10 times to get it in front of the 1, and that's where that 10 comes from. Same thing there would be with the 4. All right, 2 problems, a challenge problem. And I'm only going to do this one. This one didn't show it very well, but we can try this other one. So coefficients, multiply like normal. 2 times 3. X's, let's pull the same bases, x squared and x to the negative 4. And next will be y cubed, y to the negative 5. 2 times 3 is 6. Same bases, so we add our exponents. 2 plus negative 4 is negative 2. Negative 3 plus negative 5 is negative 8. 6 is happy, stays in the numerator. X and y need to move to the denominator because they are negative. And this one, my suggestion is to use the power to power rule and then flip your negatives. And there we have it.